What are the well-known properties of glass? Glass is an optically transparent material. Its transparency makes it ideal for architecture applications. However, this characteristic can create issues with overheating and visual glare for occupants if too much light or energy is transmitted from outdoors to indoors. Glass is a durable material that is chemically inert and has high surface hardness, which makes it also strong in compression, but relatively weak and brittle in tension. This brittleness is generally undesirable property because the glass is weak and breaks in a sudden, brittle manner. In this video, we will explain how glass is manufactured and how manufacturing processes are the basis of its properties. Here, we see the earlier view and overview diagram of the manufacturing of glass by means of the float process. The process was invented by Alistair Pilkington in the 1950s, and the big improvement on the previous processes was that very flat glass could now be produced at an industrial scale and in a cost-effective manner. Glass can be produced with different manufacturing processes such as casting, extruding, and even 3D printing. But in this video, we will focus on the manufacturing of glass by means of the float process, which is by far the most popular method. The process starts with the melting of raw materials, namely silicon dioxide, known as silica sand, sodium carbonate, known as soda, and calcium carbonate, known as lime, to reduce the high melting temperature, and calcium magnesium carbonate, known as dolomite, to increase durability and transparency. The melting takes place in a furnace at 1500 degrees C, from which a continuous ribbon of molten glass is fed and floats on a bath of molten tin. Rollers along the side of the float bath guide the glass to control the flow speed and maintain the desired thickness. As the glass cools rapidly from 1100 degrees C to 800 degrees C in the float bath, it starts to solidify without fully crystallizing, so that the interatomic bonds do not fully form. This is known as an amorphous isotropic solid. The incomplete crystallization is what gives glass its distinctive transparency, and its particular molecular structure makes glass a perfectly elastic isotropic solid that is brittle and sensitive to defects, known as flaws. The continuous ribbon of glass is then fed into the annealing oven, where the glass is cooled from 500 degrees C to 200 degrees C in a gradual and controlled manner to minimize the residual stresses in the glass, allowing the glass to be cut without shattering. The glass at this stage is known as annealed float glass and is the base product for most architecture glass applications in buildings. After cooling, the glass is scanned automatically for optical defects and is cut according to the market needs and specifications. Defective parts are automatically rejected and broken down into smaller pieces known as cullet and returned to the beginning of the process to be remelted. The most common stock size is about 6 meters long by 3.21 meters wide, but even longer sheets can be ordered. The thickness of the glass sheets is typically 6 to 12 millimeters thick, although different thicknesses are available between 2 and 25 millimeters thick. The glass sheets are then stored until further processing, known as secondary manufacturing. Thank you for watching this open glassroom video about float glass, primary manufacturing and mechanical properties, in which we have seen how the float process has transformed the production of glass, allowing for the production of high volume, large size, and superior quality glass that is nowadays used extensively in contemporary architecture. If you'd like to learn more about the secondary manufacturing processes, such as the heat treatment and lamination of glass, have a look at the second video of the series. Our references and further materials at the Open Glassroom platform.